I saw the performance of class so far, and I'm very happy. I think that students are doing very well, and that's the way to go. Just pretty much everybody is having a perfect result on quizzes, and that's, I guess, that's really something that makes me happy. I really wish we had that same grade for the course at the end of semester. So we'll just move on a little by little, and today I'd like to finally finish section 5 of chapter 6 that also discusses two more functions that deal with sine and cosine, such as a function that we have here, secant of x. And the key part to realize is that it's a reciprocal of a function cosine, which brings us to the fact that whenever cosine has a zero, what does that mean? Well, here's the graph of function cosine that, of course, repeats a lot in the left and the right direction. And the value of function equal to 0 means we're dealing with points of intersection with x-axis, because y coordinates of those points are all going towards 0. So whenever we have 0 in denominator, turns out vertical asymptotes appear, and that's what we learn in a college algebra class. And if you didn't take that class, it's fine, you just learned it. So whenever you have 0 in denominator, the graph has so-called vertical asymptote, and you can see the pieces of graph that approach to this asymptotes upwards and downwards. So the actual graph of function secant of x is composed from these pieces that I just put in the orange color, and everything else is designed to help me to produce that graph. So I'd like to graph and show you that we already have good ideas about those graphing procedures based on previous functions that we already graphed, such as a sine, cosine, and so forth. So let me find a secant function here, like exercise 29, and follow exact same footsteps as we already did before. In other words, when it's multiplied by 4, then we know the amplitude of this function is going to be 4. What does that mean? Amplitude, remember, the minimum and maximum values will be +4 and -4. Then, since it's a secant, I need a graph of cosine to help me out. So I need to get that piece of cosine bounded from 0 to 2 pi. But the period of it will be changed because of argument we have here, 1/2 times x. So I will need to bound it in between 0 and 2 pi and pull out clean letter x. And it's always like that, same plan for all. So I need to multiply by 2 everywhere, because this way I'm not going to have denominator. I'm just going to have x isolated in between 0 and 4 pi. And that's why this value on the right is 4 pi. In other words, people say the period of this function is 4 pi. Sometimes they mark period with a letter T. That's a popular notation that you can also see in this textbook. But the point of story, that piece of a function cosine that hangs here in between 4 and -4 and has a period 4 pi is now going to be repeating and giving me ability to get the actual function secant. So to get that function secant, I also gonna get this asymptotes, that vertical, and that pass through points of intersection with x-axis. So I can get a few of those. And then I'm gonna get it in a blue color so we can see it better. So from that point, we go upwards, from upper points, we go up, and from the lower points, we go down. So our graph will be a bunch of parabola-like loops or something, even though they're not loops because they're like pieces of parabola, and these pieces are on the top and the bottom, which makes picture rather messy, but I guess all that work is needed for producing graphs such as we have just done, exercise 29. Secant, or 1 over cosine, is here for us. So I just here to graph cosine, and then I hang those little pieces on the top and the bottom. Analogously, I can work out exercise with a cosecant. So if they want me to graph -2 multiplied by cosecant of pi times x, then I need to start again with a amplitude, right? 2. I say, so you switch in 2 and -2? No, -2 is always on the bottom and +2 is on the top. What I'm gonna switch is the graph of a sine function, because cosecant is 1 over sine, right? And that's why I need to get the sine function that now goes from the origin down and then back up like that. So it's flipped, in other words. And yes, one needs to be familiar with graphs of sine and cosine and others in this class, and they compose so-called library of functions, if you forgot. On the first, the last pages, there are graphs. Remember, we were always going to the very end of the textbook, to the last page, where we had that circle. Well, turns out the graphs of functions sine, cosine are all nicely gathered in those pages as well. So I think it's good to have this reference in one place. So anyways, looks like now my goal will be to get this pi x isolated in between of, as usual, 0 and 2 pi for function sine and cosine, the period is the same. So we'll be able to pull out letter x by dividing by that letter pi everything. So the left side will still be a 0. In the middle we get x, that's what we needed, and 2 is on the right. So I put 2 where it ends. So this pretty much enables me to get everything that we're supposed to for graphing. Everything means asymptotes, the ones that always pass through our intersections with x-axis, simply because they're denominator values of sine. And now I'll put again in blue color the actual graph of this functions. So it's upper piece here, lower piece, and etc. Turns out you can put some more of the graph if you want to. You don't have to, but it's fun, kind of. So the graph is actually designed from these blue pieces on the top and the bottom. That is a little bit unusual, but well, I guess that's what the graph of secant, as well as its little friend cosecant, look like. So we should see them, and then we'll see them again. And then if you take calculus classes, you will see them a lot. And that's the goal of me in spending time, so much time on this, because I think they deserve some attention, these functions, especially for people who will take more math in the future. If not, then I'm not going to be really picking much on these problems, and I'll be very happy if you know what cosecant is, 1 over sine, and that'd be good enough. But as I said, later classes gonna use these functions. Well, next section is actually the last section of chapter 6, which is pretty short, and I think we know everything that is needed to produce graphs. Again, it's about graphing, and it's about graphing of functions sine and cosine, because when you know those graphs, you can get all those other secants and so forth. So this is a pretty short section. You can see they're just about a few exercises. And what I want to do is one exercise that has a sine in it and one exercise that has a cosine. Problems are rather tedious, even though they all go under the same pattern. But I don't think for a quiz we should be having one today. I think I'd rather do a couple of problems in section 6.6, and maybe next time we will return back to ideas of quizzes. Because as I said, at this stage, I'm very happy with your quiz performance, and that's the way to go. So I'm pretty sure that you are doing pretty well. I actually can see this, and that's the way to go. And then somebody sometimes misses a quiz, so I always accept late work by email. You can send me that. And some people take advantage of this opportunity. Some people even sending me extra credit exercises that I always accept and give you full credit for that. And these points from extra credit I reserve for midterm, for finals. So it never hurts to have some extra points on your side. But again, if you are doing well anyways, then you don't have to, because Canvas has your grade up to date. You can always see how you are doing. So anyways, let me try problem with a sine. Let's say exercise number 7 has -3 with that sine. So I say that we don't really need any new information to be able to graph these functions because we already have it all. They just have a little extra inside the parentheses. Look at this close. It's 2x actually, should be careful. 2x and minus, no, plus pi over 2. Have to be careful. 2x plus pi over 2. So this is a sine function. And the only thing that I have to be a little bit careful with is its period. So that 2x plus pi over 2 is always in between 0 and 2 pi, right? That's what we just did in the previous section as well. So the goal is to pull out x. So I'm going to subtract pi over 2 from this everywhere. So we get that 2x isolated in the middle. And then we're going to need to rid of 2 with x, and we're going to use a half, right? So put 0 plus pi over 2 is just pi over 2 with negative sign. And I'm not going to do this arithmetic. I'm just going to keep it the way it is. 2 pi minus pi over 2. So this way will be easier, I think, to see what happens. So instead of dividing by 2, I can multiply by 1/2. It's convenient when you work with fractions. So if you multiply by 1/2, the 2 will still be in your denominator, but that way you're going to see what's with the other pieces. Like first one will turn into pi over 4 with a negative sign. The next one will be just a pi minus pi over 4. So this clearly enables me to get this boundaries for our piece of a sine function. So notice I start at negative pi over 4, and then I move it by pi to the right direction. And that's how the sine, because we have here sine with a negative in front, so it'll be like minus 3 times sine, piece is bounced in between, just like that. So it turns out, since this is pi for the period, sometimes people even do it like that. I already shown you, right? So that they say t, the period is pi, because we move by pi from the left end to the right. That's called period, right? So sines and cosines are periodic functions. So then half of it will be here, and the axis, which is y axis, will be passing exactly through that point. So the lowest, our -3, the amplitude now, right? It's -3, and the highest is +3, will be up there. And I completely described function that we have here. Other than we can just continue this to show that it actually doesn't stop, but goes a little bit to the left and to the right. I'm going to say, how many pieces do I have to put to the left and to the right? You don't have to. If you leave it like that, it's fine. I'm not picking on my students when grade their tests, but it's good that you show that you realize and the graph does not stop at that stage. Yes, that's good enough. But some people sometimes say, oh, I want to get 2 periods, so I put a few more wiggles and more wiggles and more wiggles. And well, you don't need to do that. But if you want to, why not? So anyways, we just graphed function sine, and yeah, period is always positive by how far you're moving to the left and to the right. So let's say from here to here, you add period, which is at pi, like that. So it's always positive. You say, can it be negative? Could be negative, but I mean, positive, negative, it's pi. It's, I like negative pi. I like them to be negative. Fine with me. It could move to the left by negative pi, but to the right, it's still by positive pi. But again, see, it's not that principle. The point of story, you know, by how far you move into the left and to the right, that's your period. How far you're going up and down, that's your amplitude. But those are important, of course, values to clearly mark down, because that way you show that how graph is bounded, and that's pretty much all you need. So we just graphed function sine. Why don't I graph function cosine? Looks like this section, I kind of wondering if it's really needed here, because In addition to always starting at point 0, we actually start at like 5 or 4, simply because we have a little bit of a extra shift here, right? Because we have a little extra number added or subtracted. I guess this is the whole point of this story. So let me get a cosine. Let me get a cosine, like in say exercise 12, for instance. And also in this exercise, there is -1 at the end. So that -1 is going to shift the whole picture down by 1. And at this stage, I'm not going to draw it. I will, first of all, just produce analogous graph to the previous exercise. And later, I'm going to drop it by 1 unit downwards. So that function cosine with the argument 2 pi x minus 4, whatever it is, doesn't matter to us. We're going to pull out x. So I start out same way for all of them. I surround it by 0 and 2 pi. So then we can drop, actually add 4, right? Because it's -4, so I have to +4. So we start now at 4, and it's still same 2 pi times x, and the 4 is canceled. That made me feel good. That's actually our goal, because we're pulling out letter x. So I just put +4 here. And now 2 pi needs to be in denominator, right? So I need to put 2 pi in denominator. So I put 2 pi here in denominator on the left side. On the right side, I put 2 pi under both pieces, because this will enable me to actually cancel. And I just love to cancel. That's my favorite procedure, because things get simpler after we cancel. So 2 over pi is the left side. And then the right side will contain number 1 plus another 2 over pi. And again, this way of doing it clearly shows me the period for this function. 1. See, why is it 1? You start with some place and you end up with 1 plus exact same number. So you move by 1. And that's why period is 1. And this is great, because now I have to put my function cosine. It starts somewhere on the y-axis. Again, this is what I have to remember. And then ends at the same level. This level is now going to be amplitude 2. So -2 is on the bottom. But now it's shifted. Notice it's no longer at 0. So how can I fix that? I'm going to clear this axis, and I put whatever it starts at. 2 over pi, fine. I say, what is 2 over pi, Alex? Well, pi is like 3.14. It's like 2/3. So it's some kind of positive number. And then you move it by 1, so this ends at 1 plus 2 over pi. And that's enough. I described completely the piece that repeats, but I need to not forget about -1. So now I have to move this whole picture down 1 unit. I guess I'm going to use another page, because otherwise it'd be a mess. So now I have to move it down. So I'm going to subtract 1 on the y-axis from my upper and lower pieces. What does this mean? Well, the upper piece is up here. So I'm going to have to go -1. So it'll be at level of 1. And the lower piece is at the level of, so the axis is someplace here. So at the level of -2, not -2, so it'll be -3. So my y-axis will be having values from 1 to -3, because the whole picture is dropped down. Why? Well, again, we subtract 1. Let me write this again. We have a 2 cosine of whatever in the parentheses, 2 pi x minus 4, and then subtract 1. So that's what made me do this shift downwards. So the cosine, we hang in that somehow like that. And the key parts, the points, will be starting at pi over 2, sorry, 2 over pi. We say, why not pi over 2? It doesn't matter. It could be anything. And that's good to realize. They can give you whatever numbers they want. Main thing is not to panic, but just give them this piece that varies between -3 and +1, and has a period. So clearly, the period of function cosine we have here. And one says, is that enough? Should I put more of it? You don't have to. I will understand. But if you put it, that's going to look nice. So something like that. So that's all I think for chapter 6. It's a good time to stop at this stage because exercises, they look a little bit unpleasant, I want to say. I don't want to overwhelm you. If you redo exactly the same pair of problems I just did from section 6.6, I think it's plenty. I think it's plenty. And I hope you see the pattern. It's all the same. You always start with 0 and 2 pi. So you always surround by 0 and 2 pi, and then do a little algebra to pull out letter x in the middle, right? We always want to get letter x because we graph x-axis, not 2x-axis or whatever. So we need clean x. And that's about all I can say here. So the next will be chapter 7. Gonna talk about this chapter 7 on Thursday. And chapter 7 has its own interesting specific. It gives you some more trig functions, the inverse trig functions. Inverse functions is what we're going to discuss next time. But I'll go pretty slowly. My goal will be you getting used to these interesting material, because I know it's very new for most people in class. So last thing I want to do is hurry. And I'm glad that we're able to take a test in unlimited time format. I hope this way you will feel much better about it. We're actually going to have a test a week after next. I put just 2 problems, not something very lengthy, and give you like a day. Somebody says, Alex, I need 2 days, 2 problems, 2 days. Okay, 2 days. I just want you to do it right. So the time is not an essence for this test, and I will send you next week practice test, so you're going to know what's on that test, the same problems, it's just different numbers. Like here, what'd be the difference if I put not 2 pi x, but 3 pi x, whatever, pi over 2x, same thing. So you will know what exercise you're going to get on that midterm exam. So we're going to discuss it in very detail next week. But so far, I'm very happy with your performance. So I'm sure if you continue like that, everything will be just perfect. And that's my goal. I want you to get a perfect grade. I think it's fair, right? Because you deserve it. So I'm going to end it for today. No quiz. I think we already had quite a few quizzes. We'll have some more when time comes. So